I just want to tell you a little bit about the Science Gateways Community Institute. It sponsors this. We're funded by the National Science Foundation to provide support to Science Gateways in three main capacities. And the first area is support for building and running gateways. And we provide that through both consulting support with hands-on programming and software development, as well as advice from consultants on topics like usability, cybersecurity, and so forth. We also offer a catalog of gateways and software, which lets you find tools or examples of gateways that might be either something useful for building your gateway or a model for what you'd like it to be like. In the second area, we offer a lot of education and training. Obviously, this webinar is an example. We also run a program called Focus Week, which we've been running virtually in the past year, but it's an intensive opportunity to think about the future of your gateway and how to develop it. We also run a number of student-focused programs, including internships, and we have a bunch of additional resources and materials on our website. And then finally, we wouldn't be SGCI without the community in our name, and so we offer a lot of things with events with that in mind. So our annual conference is one way to connect with other people face-to-face or online, as it was this past year. We have an online Google group that is a forum for posing questions directly to other people who may have experience with questions that you are puzzled about. We have a couple of ambassadors programs and affiliates and partner programs. And we also always welcome input from the community in terms of news, guest blog posts, and jobs. If you want to send those job postings our way, we're happy to post them on our website. But also, if you have a topic you'd like to write about for a guest blog, let us know. Finally, I just want to say, the way we demonstrate that we're providing something of value to the National Science Foundation is to get your feedback about this. We also use that feedback to think about what other topics would be useful to our community. And so if you do have a half a minute or less to provide some feedback, I will be posting this link partway through our session, and you can give us feedback there. Really, it's 2 questions asking you about how you liked it, and then an open-ended question if you'd like to suggest topics that we could cover in the future. So with that, I'm going to stop sharing and hand it off to Boyd Wilson. So Boyd is going to talk to us today about CloudyCluster, where he is running the show, I should say. But he also has Amy Cannon here with him as a trusted side, what do you call it, side person? Anyway, she's available as well to answer questions in chat. So, so I'm just going to let Boyd take it away, and we all get to learn about CloudyCluster. So thank you, Boyd.
Well, thank you, Catherine, and good morning or good afternoon, everyone, whatever time zone you're in. Appreciate you taking the time to sit in and listen. And feel free to ask questions during the chat. Excuse me. I like interactive, and other people probably have similar questions as we're going through. The focus of the talk today is on cloud HPC integration, and I wanted to kind of start out giving a little bit of background on Omnibond. Omnibond's a software company. We're actually a spin-off of Clemson University, so our roots are academia, research, and on the leadership team we have a former chief operating officer of NCSA, who's also a CIO at Purdue and Clemson. And I was software CTO at Clemson, also spent time director of computer engineering at school at Miami of Ohio. We've done various, Jim and I have been in academia and research computing for years. So we understand where people are coming from. We understand, where funding comes from and all those types of things. And back in the beginning, Omnibond was actually a back-end engineering company for Novell when it kind of initially spun off of Clemson, and then did work in the open source parallel file system, OrangeFS, and then more recently, computer vision and AI-based traffic vision, and then cloud HPC orchestration with CloudyCluster. So we have a lot of software experience, software development, back-end engineering, and we also have a lot of academic experience that we try to help communities with. One of the things that's interesting, if you look at the history of the cloud, is, why did so much of traditional IT go to the cloud? And in the beginning, if you go back and think about it, there was e-commerce with its seasonal scalability, unsteady workloads, or things that were not predictable. Those things made sense to, like you go rent a car when you're on a trip, to go rent some computing in the cloud. And as those capabilities grew, then it became more massively scalable. Things like Netflix and other things started just running native on the cloud. And you started to see this space where people didn't have to have a huge amount of investment to have a data center available. So a lot of startups, and kind of changed the way we look at things. It also provided a bunch of cloud-specific technology. But the things that started, I started to see when, it came into academia and research, is really on the production side of the house, where you had, 5 different dev, test, and QA systems, and then you had a prod system, and you had hardware for all of that, and you had storage replicated for all of that. And pretty quickly, it became apparent as the cloud matured that it's a lot cheaper to have dev, test, and QA when you can turn it on for the week you need it, and then turn it off, and you only have to pay for those weeks. So, the 8-to-1 cost savings were significant. But throughout history, HPC has been more efficient. It's always been a more efficient use of hardware. The batch schedulers solved all that, and campuses, generally shared their traditional, IT or their production IT with their research IT. So there was cost scalability. But as traditional IT moves to the cloud more and more, HPC is going to have to, have the burden of more of that overhead cost. So what is the cloud HPC opportunity? What can it provide? One thing that's interesting, now we're at a scale where, instant compute availability, you don't have to wait. Instant storage availability. If you need something quickly, you can spin up a whole bunch. Once you get, the limits and quotas increased, it can be available for you. And you also get a set of diverse resources: GPU, TPU, FPGA, and even if you think about how quantum is going to come into the world, it's probably going to come in as a cloud offering, in one way, shape, or form. And then you continue to have that massively scalability, and then also, again, cloud-specific technologies. And but then when you're ready to do like high performance computing, you're thinking, what about latency? I mean, you might be launching things all over the place. What about scalability of workloads? Not just, okay, yeah, I can run 50,000 web front ends, but what about actually, my codes that need to run? And lastly, what about cost? So we've been working in this community for a space, but these are the things we look at. What could cloud HPC look like? And these are some of the things we thought about in the beginning, and these were also things we've added, since we've learned and iterated and working in this space. What should it provide? You should have the ability to take your HPC jobs, run them on-prem, just like you do. I have run on my campus cluster, then I go over to Exceed. You should be able to take that same job, get your data set up, and then run that in the cloud. You should have the same software available as on-prem HPC clusters. You should support all the capabilities of the cloud, but still have this, backend compatibility with, on-prem. You should be able to have job expenses tied to billing. That's something that's been around in HPC shops for a long time. And jobs, this is unique to the cloud, but jobs should dynamically scale up as needed and then tear down when they're done. Your typical on-premise HPC environment, you have, shared resources. So this job runs, when it's done, another job takes its place. In the cloud, it's a little bit different. You're just kind of becoming a dispatcher, not necessarily a scheduler. Should be able to have tiered data for long-term or short-term storage, and then high-performance scratch storage, and the same components that that you see on-prem to make pivoting back and forth between easily. And so you have your login node, your scheduler, parallel storage, add the capabilities of object storage, etc. And we should also be able to be optimized for cloud-specific features in the future. One option is to go build it yourself. As we learn more about the cloud, we realize that the API-driven nature of it is really where it became powerful. That's where it became backends for Netflix and all these startups that went to the cloud. They just used the APIs and built their apps around it. And when you do that, you have to deal with images, instances, VPCs, firewall configs, security constructs, auto scaling, keeping up with the latest capabilities. The cloud's moving really fast. Object storage, parallel storage, all the different instance types that keep getting added, all the different GPU types. So those are the things that it's a little different than buying a fixed cluster on-prem, installing the software. You have to kind of dynamically allocate. And we kind of thought about these things as we built CloudyCluster and said, can we build a tool that's cost-effective and easily used for these, so everyone doesn't have to go build their own. And we think of CloudyCluster as automated cloud cyber infrastructure. And we really want it to be automated, so you can automatically deploy a fully functioning HPC, HTC environment. We wanted to provide users that familiar HPC, HTC experience as they do on-prem. Have those HPC applications, libraries, all pre-configured on the image. Excuse me. And the one thing about job scripts, it's very interesting that job scripts over the decades has become kind of the instrument or the interface to computation. It may not be the best human interface, but it definitely is a good machine interface. So it made logical sense to extend those. So we actually, as part of CloudyCluster, built a metascheduler. We'll talk about it in a minute, but we tried to make it so these job scripts can determine the resources that are used. Just like on your standard cluster, when you want this many cores or this many nodes, it'll route you to where it needs to. But now you have all these additional, standard preemptible GPU, all the different instance types, CPU, local storage, all those things, the job script should still do that. And so we tried to implement that. Slurm and Torque, front-ended by our metascheduler. People are used to job scripts. That's that pivoting. I want to take the Slurm job script, run in the cloud, run it back on-prem. Parallel and object storage. And one of the things we want to do is operate in the customer's own cloud account, because for security purposes and things like BAAs, if you're doing medical and healthcare work, you don't need a third-party BAA if it's running in the customer's own account with us. And there's the billing label integration, and then taking advantage of the things like placement policies. How do you take advantage of those things that are under the covers in the cloud to make these workloads work very efficiently? So here's kind of an overview. You can see an architecture to the right where you have the control node as kind of the head node. It spins everything up. You have a web UI to do that. And then you get your login instance. You have your scheduler instance. Like I mentioned, it can be Torque or Slurm. And then you have your parallel storage, and it's all can be wrapped in a VPC. And then you can dynamically, based on job submitting, have those compute nodes spin up that are needed for those jobs, and then tear down when they're done. And we've also just recently integrated Open on Demand. We'll get to that in a second. That was one of the first cohort of projects I went through the Cloudify Gateways project with SGCI. So that was, a very interesting project. And you can see there's lots of HPC libraries, HPC software, but we also made it so you can easily add your own, because we know you can't get everything right. And you can easily just launch an image without launching CloudyCluster, and then you can add the software you need, save it, and then launch CloudyCluster. So we've tried to kind of have the best of both worlds there. So regarding scalability, now this is a high throughput workload, but we were able in 4 hours of runtime to spin up, process 2.4 million hours of, video data for traffic analysis across the Southeast. And kind of come up with speeds, counts, congestion levels, those types of things in a very quick run across a wide variety of stored video or cameras. And we're able to, do 2.1 million vCPU hours, within 3 hours. And that was concurrent, ramp up time and then tear down time. And, in processing for, several, 90 minutes in the middle. You can kind of see the curve as it kind of scaled up, tapered off, and then shut down very quickly. And the total costs, these were all preemptible, were $52,000. So they're very, $0.008 per vCPU hour. So it can be cost effective. And it was an interesting project. And you can scale high throughput workloads. When you get more specific to high performance workloads or MPI workloads, there was an interesting study done by the group up at University of Buffalo that does XDMod. And you can see the difference between campus HPC usage, the number of CPU hours and the number of cores along the bottom. And you can see that there's not very many. A few instances in the cloud could do a majority of what campus workloads do. It wasn't until they went to the bigger NFS centers equivalent, TAC and those types of places where you really see the larger run. So a lot of what campuses can run in the cloud. And that gives that ability for people to have that in their tool belt that you can go, hey, queues are long today, let's go run to the cloud. So it gives flexibility to do those things. Or certain funding comes down from NIH and they want to do it in the cloud. Those things can be done now. And early on in the cloud, that wasn't really possible. Even more recently, trying to solve how do you do MPI workloads, and working with Google Cloud, they've been working internally to reduce their latency. And we collaborated with them, and we actually built the latest version of CloudyCluster on top of the Google HPC image. And we're able to see in this graph compared to on-prem, there's an on-prem system, there's, Google Cloud regular CentOS image, and there's the HPC optimized image. And you could see the scaling over multiple nodes and the runtime decrease as you expect with the SDVP, algorithm. This was done in conjunction with Walter Landry over at Caltech. And you could see scalability, the latency is getting there. We're finally getting to where you can actually run these workloads in the cloud. So it's really exciting. As we mentioned before, obviously we work with science gateways a lot. Catherine mentioned that in the beginning. We do the Cloudify gateway solicitations. We also have sponsored numerous hackathons at SC and PERC, and we'll continue to do that and kind of help coordinate and collaborate with that. And Amy does a lot of work behind the scenes with those. And then internet too as well, with the network connectivity and those types of things. So one of the ways people want to say is, how do you run it? You launch it from the, this is the Google Cloud Marketplace. You can also launch it from the AWS Marketplace. Costs about 5% of the on-demand costs. So you only pay for what you use. Through Google, you can also buy it in a subscription. And we'll get to that in a sec, because that's something very exciting that they're trying to do to help with, making the cost less risky for universities and public sector. So the one thing we'd like to point out, as we've done several of these Cloudify Gateway, projects, there's a couple of different configurations that fall out. So you have a science gateway that runs on-prem, and it runs against a local HPC resource. And what a lot of the projects have wanted to do is add the ability to have CloudyCluster kind of be an option, so you can launch these same jobs in the cloud. And the gateway, provides that, unified interface, and that can be done for a number of different reasons. It can be done because certain researchers have funding that goes there, or, that there's queue capacity, or maybe you want to send, commercial customers to the cloud because, it's hard to, get them to use the on-prem system because of agreements and such other things. So that's kind of the first model. The second model is kind of a cloud native option where you actually spin up the gateway as, on top of CloudyCluster, say on the login node, like we did with On-Demand and Open On-Demand, and integrated that. And what's interesting, we have some people going down this path because then commercial partners can actually launch a full environment with a gateway, have it up and running in the cloud. And then you don't have those agreement complications with, using compute at, various different places. You have broader researcher reach. There's a lot of institutions that don't have access. And you can also kind of build a turnkey gateway option. So this is kind of an interesting solution that's kind of evolved over time. And we're happy to work with people to kind of figure out how to plug these things in and make them work efficiently. And as I mentioned, this is Open On-Demand, and Open On-Demand is actually working with the groups at OSC and UB and VT, all helped us kind of integrate. We did this proof of concept of where Open On-Demand ran on top of CloudyCluster, and then we actually kind of took a little further and fully integrated it. So out of the box now, you get Open On-Demand running on top of CloudyCluster. You can connect to your Jupyter notebook. I only gave it an hour a little while ago when I launched it, and you can have Jupyter Lab running, accessing, running on an instance just like you would on-prem. And you have your file access, which is really cool. Open On-Demand has the ability to drag and drop, and then you also have the interactive desktops and the full power of Open On-Demand sitting on top of CloudyCluster. And so that was actually a really fun and exciting project. We've had a lot of interest from a lot of different universities in this. I'll share these slides with everyone. I kind of like to put in cloud cost comparison so people can see how the different vendors, compare it. When this Kinsta thing was done, I think it was maybe early 2020 or late 2019. I should have that date on there. But
can I pause you for a second there, Boyd?
Yeah.
To go back to that cost slide. So we did actually get a question from Rajesh asking, he said, it's interesting to hear of the new HPC VMs on Google Cloud Platform. MPI scaling in the cloud was one of the issues I've had in the past. How do costs compare to the traditional VMs? The more compute-oriented C2 instances were quite a bit more expensive to begin with.
Right. So what they did, if you want to get the full low latency, you need to use the C2 instances, and what you'll need to do is put them in placement policies, and then it's actually an HPC, not a VM. It's actually an HPC image that is optimized for the latest round of C2s and how they're deployed. So that's where we actually got that lower latency with the tuning based on that C2. But it was the placement policies that when you launch in those placement policies and they end up close together network-wise, that you don't have one outlier sitting out somewhere slowing everything down. And the one thing about costs is you want to make sure that you look at the discounts that are available. If it's NIH work, make sure you're looking at the Strides program. Make sure you're negotiating costs, looking if your workload can do preemptible. Preemptible is not going to work as well for MPI workloads that are large. And then how do you kind of extend from there? And then Cloud Bank. We've talked to the folks at SDSC that run Cloud Bank in the past, but we haven't done anything specifically, but that'd be an interesting conversation. So if,
we should make sure we mention that question, what the question was for future people listening, which was just, are you having much interaction with Cloud Bank?
Yeah.
So, yeah.
Yeah. Okay. But
now, and there's a comment too from Rick about the fact, he says, CloudyCluster sounds like a good fit for folks with cloud credits to do specific NSF sponsored research projects. Is that how you see it happening?
Yeah, I mean, we could easily make that work if people want to use that. If they have credit specifically for Cloud Bank, we can, let's get in touch. And we have a very good relationship, especially with Google and AWS, so we can actually, help do that.
Thanks.
And then the subscription pricing is what's pretty interesting. And what Google has done is they've kind of developed an IRU model. If you remember, networks, you think about the right to use. I have the right to use this. They've come up with this subscription where you negotiate ahead of time and say, these are the workloads that we want to run on the cloud. And we're helping from an HPC perspective to kind of say, okay, this is what it'll look like in the cloud. This is what it'll cost. And they'll actually fix your cost for that project or set of projects. And then based on that, you only pay the same amount every month. And then at the end of the year, if there's some cost overruns, some grad student left GPUs running or something for a little bit of time, things are within reason. They'll kind of keep an eye on things every month. And then you can decide to say, oh, we want to use the same this year. So Google has skin in the game now. They're willing to kind of hold the risk for overruns for a pre-negotiated set of workloads that can run in the cloud. They were a little bit hesitant to bring HPC in, but we've been working with them, and now HPC can be a part of this program. And so we're really excited. So this is another way that you can put compute in your grant, come up with ahead of time for it, and then that over the years of your grant that's going to be fixed. Or if you want to use it for your internal infrastructure, you can fix that cost and not be afraid of some overruns. And Google sees the advantage in this, that without that risk of overruns, you'll be more willing to use it. The only risk that you have is if you don't use enough of it on the other side. So it's actually pretty exciting that they're trying to kind of solve this problem. And so then all of a sudden you don't have to worry about, oh, what is this going to cost me to download? What is this going to cost me to run? It's been pre-calculated, pre-agreed upon, and then you get to move forward. So it's actually an exciting program.
Are you, is CloudyCluster helping people figure out what that amount would be? Or is that something that's more obvious to someone who actually knows how this stuff works? Or, I just wonder how you would figure out how much you'd be subscribing to pay for.
Right. Yes, we will definitely help with that, especially with the HPC workloads. We've done this, a couple times. It's a new program as we're developing it, but we'll sit and say, hey, here's the workloads, here's the project, and then we will definitely help as part of that. And then, we work with the Google SEs and the sales team to actually kind of pull it all together. And this can be done under any of the other contracts. This is kind of an addendum or something. It's not necessarily a whole new contract that has to go to legal. It can be done through, the purchasing vehicles that you already use.
A question came through too was, is there an enforcement mechanism for Google Cloud subscription, or do we have to constantly monitor?
So it's not really enforcement. If they understand, Google understands as part of this is there probably will be overruns, and they kind of assume that there will be, and you just you don't have to worry about all this keeping track of, and you keep track month to month, but you pay the fixed fee and you use the compute, and as long as it doesn't look like you're abusing and trying to stay true to what you were trying to do. The next year you might have to adjust and say, oh, these things took a little bit more than we thought, or we want to add this project the next year, and then can do it. But it's not really a monitoring thing anymore. It's more of a monitoring just to kind of make sure you're staying close and you're using. Google's more interested to make sure you use what you're there, so you don't come back the next year and say, hey, we only used half. That's their biggest fear. So they really want people to use it even a little bit more. But from an enforcement perspective, that's kind of a difficult thing that the cloud providers are facing. Is if somebody has the Nobel Prize saved on storage, do you delete the storage? That's not the position they want to be in, let alone the legal liability of doing things like that. But there are tools and ways, and we're trying to think of ways to be a little more friendly to kind of cap certain things from happening. But right now it's kind of a monitor where things are, but the subscription means you don't have to come up at the end and pull out the credit card from a budget that doesn't exist and pay for something. So it kind of reduces that risk from that aspect. I hope that makes sense.
That's helpful. Thank you.
So one of the other things that we try to do is we try to help. There might be institutions where everyone's busy, they don't have time right now to kind of go through this stuff, and we can help with the cloud image customization. We can help with better billing integration, data staging back and forth, identity management integration, so the cluster has the IDs that you want. We already integrate with in common for the web login, but there's the SSH backend that might be nice to integrate. And then there might be options for integrating with the login node, or even integrating with the on-prem scheduler. Those are kind of consulting add-on things that we can do. But we really try to make a product, or a product-oriented company. We try to make things that kind of come out of the box and are very usable. We don't, our goal is not to write consultantware, but we do know that people need help, and we do offer those services. I think I went down 20 pages. Yeah. Anyway, here's a couple of projects that I'll kind of go through really quickly, that they're in the deck that people can refer to. We're doing some work now with University of Michigan with the Cienfroco lab, trying to do some Relion work with cryo-EM and processing that in the cloud. And it was really exciting because we were working with them a few weeks ago and launched a Jupyter lab through CloudyCluster with Open On Demand, and then kind of discussed, well, do you do this to, do you just use the job interactively with the GPU node, or do you launch a batch job so it comes back later? And it's kind of changing the way they thought about workflow. So it's kind of exciting, maybe they'll just kind of interactively look at this, because a lot of their things are, single node GPU based right now, but having the ability to interact with it real time was pretty exciting. And then you turn it off when you're done. We've been working with Galen Collier at Rutgers, and he's looking at various different ways to do, research support, sharing best practices, introducing cloud as a tool. They have a big on-prem system, but there's some places where cloud might make the most sense. They have with this weird software that runs, they want to meet some security requirements. So, they're looking at various different things to leverage it and use it in conjunction with their on-prem system. And, it really wants to integrate it with that. And then also make it part of the student, workforce development. As people go to other places, the cloud, if they take their HPC skills and can automatically leverage it, in addition to other things like other, cloud tools and capabilities, it's very interesting. So there's several projects that are ramping up that look very exciting and very interesting. So again, we'll leave these for you. If you're interested, there's research credits. We can help you get those if you want to try something out, try to kind of navigate the process. So please, let us help. And actually even PhD candidates can now, get that. And then I left a couple of other projects. This is it's a proteomics project, doing some work in the cystic fibrosis, looking for the CFTR protein and how it interacts with a broad search. And they leverage CloudyCluster to do that with their IP2 pipeline. They actually had some publishable results. It was very interesting. This is the Yates lab. And then University of Denver built a biomedical ontology where you could actually, it's kind of like, a build system for biomedical ontologies. It went up, and if any of these ontologies changed, you actually were able to, it would go and say, oh, that one's changed, let's validate it. And they run through this validation process, and sometimes there'd be lots of HPC jobs that run, sometimes there'd be none based on the data would change. But he had trouble on-prem where some of the stuff would run and then you get stuck behind some queues. And, he had so many different jobs testing a lot of the different ontologies, a lot of different, things in the ontology. It was easier in the cloud because he was able to control it, launch it, get all of it done, and then tear it down. So it was kind of a fixed chug and go, and it was just data driven. So that's a very interesting project. And there's kind of the summary. We saw the ontologies and hit CloudyCluster, and then have that continuous integration system. Now, if you want to get started, one thing that we try to be a little more hands-on and helpful, that allows you to, not have to spend so long just getting up to speed, because everything's a little bit different. So we're willing to sit through and launch the first environment with you, maybe get a little job running, help you kind of think about the first thing. So, we try to be a little bit more hands-on, a little bit more customer friendly than a lot of the cloud folk. And it actually is pretty simple. You need a GCP or AWS account, then you launch it from the marketplace, and then you set it up, choose the size of your environment, and then CloudyCluster automatically generates the environment for you, and then you can do some sample runs based on that. And then Open on Demand is up and running as well at that same time. There's a couple of videos that'll walk through that you can look at your leisure. And here's some basic contact information if you want to reach out to us. So just curious if anyone else has any questions or any other ideas or thoughts.
So anyone, we do have a question that just came in. So Kenneth says, I would like a way to set a monthly or yearly cap on spending with an enforcement mechanism that shuts everything down if that limit is exceeded. The alternative to cloud is bare metal, fixed price servers run all the time. If I know how much it's going to cost me, the bare metal option is more attractive. I don't know if that's a question, but it's sort of a statement which could earn a reaction for sure.
Yeah, and the one thing I want to point out is that subscription model is a billing cap. They stop charging you even if you use more than that. And so that's the best of both worlds. And now there is a price to get in that. You asked about Azure. Microsoft reached out to us a few months ago. We're talking about that. We're having discussions with them about porting to Azure. And so if you have a specific project in mind that you want to do in Azure, let us know. But there are also scripts. I know there are scripts that you can run in Google that when you hit a billing level or get up to, you can trigger everything to shut down or tear down if you want to. If you're okay with the data being destructed, but it's kind of one of those things you have to put the trigger in there, and then things can all be terminated and cleaned up. So there are ways to make sure you absolutely don't go over a billing amount, but they're kind of draconian. But there are ways to do that.
And then Rick asks, I just want to make sure we read the question so folks can hear it in the future. Have you done any work on near real-time instance optimization for workload and batch scheduler policies, for example, multi-tenancy?
So real-time instant, I may not understand. I mean, you can select, the quality of service in the cloud is pretty good now from all the vendors. And so, you kind of get the level of service that you're expected. Earlier on in the day, someone else could kind of steal more systems, but the quality of service is pretty good. But if you're speaking of, hey, I want to launch this, what type of instance do I need to know? I guess there'd have to be some interaction between the workload and what's running behind it. I mean, we can automatically, we can scale based on the, the number of jobs that come in, but not necessarily, change the tuning of it. It's something that's running real time. But maybe I didn't answer that.
Rick, do you want to unmute yourself and clarify it all? You're welcome to.
Yeah. Hey, Boyd. Amy,
hey, Rick.
Everybody. So the question is more along the lines of, okay, if I have a traditional HPC cluster layout and I have, so many instances, can I either collect information that would help me decide whether to add more instances, or if I didn't like multi-tenancy initially, and I was having what was essentially a high throughput workload, could I potentially, get information from CloudyCluster to let me know that I'd want to change that policy so I can optimize memory usage for the instances that I'm currently using?
That's a really good question.
Are you starting with sort of a static notional cluster layout that you think is going to be okay and just go with that, or are you collecting information that might help you optimize your spend over time?
So there's two ways to launch jobs through the Metascheduler. And one way is you can hard code the instance type. So you can say, if you want the C2 instances because you want the low latency, and we'll automatically put them in placement policies so they'll be close together if there's less than 22 of those instances. And that number will be increasing. Then you could hard code and you'll always get the C2 instances. If you just use your typical Slurm SBatch commands in the job script, and you say, I want number of nodes, number of tasks per node, it will actually automatically choose the cheapest right now. And then it'll launch those based on, your Slurm configurations, if you haven't, hard coded to a specific instance type or something out for helps for other purposes. So, and for every job that is configured, and those nodes will run. And again, like I said, we're dispatching jobs based on what the job puts in. Now, the one thing, if we wanted to learn more about requirements, we have kind of talked off and on in the past with the XDMod folks, to kind of get integration so you can get those real-time metrics of what's the usage of this. And they were doing a little bit more work in the cloud last time we spoke, mid last year. And so, that's another option that we're looking at to provide that better insight, because you don't want someone spinning up a 40 core instance and using 3 cores or a terabyte of memory and they need 100 gigs, those types of things. So we're doing some, but we want to do more in the future. Does that kind of answer?
Yeah, absolutely. That's good to know. One of the biggest issues is for sort of ad hoc usage of cloud resources is not knowing what it's going to cost, but having enough faith that you're not going to blow your budget to be on a path of continuous building a better understanding of what your resource requirements are. And I think
and one of the things
might be a good piece to integrate. I mean, I guess it would be overhead, in some sense, like your Slurmd or whatever your controller node is, but it would be good to collect that information.
Yeah, and we do also write out in this latest version everything to the respective cloud logs, so you can go back and review stuff. But so some of the usage stuff, is very hard to kind of dig through and understand. Where XDMod does a nice job of kind of collecting that together. So yeah, but continuing to kind of work down these. One thing we do is with the Metascheduler is if you launch the job with a -PR, I think is the command, it'll actually tell you how much that job is going to cost per hour. We can't predict the number of hours it's going to run, but if you know, hey, that ran on-prem and it ran about this long, you could do some simple math to kind of go, oh wait, that's not quite what I was thinking, or oh okay, that's within reason. I think it's when people run jobs, they realize they don't cost as much as they think, because they're not running all the time. Where people get into trouble is they launch a few GPU nodes, they leave them running, and they come back 6 months later, and they've been sitting idle all that time burning, and that's where the things people go, oh, that's where the overruns come from. And again, that's where that subscription model, Google knows that they'll kind of ignore those the first year because it's a learning curve thing, and then the next year, everyone knows better because, oh, hey, don't do that. Here, let's do better, or let's do these scripts like, Kenneth mentioned, or other things. But
sounds like a good job for a Slurm plugin. You could call it the out of money killer.
Yeah, and we like doing that at the Metascheduler level, and it's pretty easy. And we're doing some work to do some other integrations with the Metascheduler and doing some work with the ERN group. And as part of that, we're looking at, having project levels and pull the billing against that. And someone can't, if they're in this project group, they can't launch more jobs. Do we cancel the job? That maybe that's an option. So I think those things are doable. What gets more difficult is, and storage is a lot cheaper relative to compute. That's the one thing, I learned in the cloud early on is kind of surprising. is do you want to delete the data? You know, I mean, stopping someone's compute, yeah, they might get grumpy at you if they have a deadline or something, but that's not as bad as deleting someone's data. So I think there's kind of levels in the middle that you can slow down, you stop the rapid burn and kind of leave a dull roar down there, and then people can kind of see what they want to do and clean it out. And the one thing nice that I do like about Google is if you ever want to be done, they have this nice project-based system, and you hit delete on the project, everything's stopped. It's put in, you know, this delete queue for 30 days that you can actually go have an oh crap moment and go get stuff, but everything's turned off, gone, and billing stops. And so you do have kind of that way to know that everything's done within a project. And so there is that delete all button.
It does sound like it could be pretty intimidating. It's a good thing there's a buffer there. I have a question which might have been answered at the beginning that I just didn't understand the terms well enough to know whether you were answering it. But how does the cost of CloudyCluster fit into the overall picture of the cloud subscription or non-subscription, whatever it is that's being used to access that specific cloud? How do the two fit together?
Right. So there's two pricing models for CloudyCluster. Generally, we do about 5% of what the on-demand costs would be. So when you run a job or you're running the environment, you're paying a 5% overhead, which you can usually get a discount over that if you're talking to your cloud vendors off of what's listed, you know, just for like the regular price. But we're about 5%. So we try to make it cost effective, make it worth to use this. You know, we'll save money by turning stuff off automatically at the end of job runs and things like that. Now the subscription model also, that, you know, that prefixed price that we've also, you know, worked, you know, Google's asked us to make a, you know, a model that fits on top of that. So we do a 5% on top of the fixed model. And then it's a no overage, same type of thing as Google, you know, the Google subscription. And we also have the ability to do special pricing through the marketplace and certain things. And we do that for trials or demos, and we want people to try it out as well. And we can do those things as well.
Great. I do remember you mentioning the 5%. And I didn't quite grasp that that was what it was for. So that's terrific. Now, Rajesh has a question. He says, would you mind saying a bit more about user/access management in CloudyCluster? I assume you can set it up so non-admin users only get access to the login and front-end nodes?
Yes. You can add, we call them collaborators because we were trying to be cute, or that's my fault. But you can add users to the system, and they have just the access to the login node. They can SSH in, and we actually have scripts set up. So you can actually, you know, when the control node is running and the login node, you know, kind of is there and available, we can actually run a script that'll, you know, take certain on-prem users and run it into the cloud. So it's kind of that IDM integration. We can do tighter integration. Users can be, you know, set to log into the web if they want, you know, different methods as well. But yeah, users can be set up to just have access to the login node. And let's see, you know.
And Mona had the question about the 5% and whether it includes support, like development support if needed.
So we try to be helpful if it's simple, helpful questions. Yes, you know, if you want to integrate, you know, one thing with it, then that makes sense. If it's more involved and we want to do some more tighter integration, you know, then there might be some charges on top of that. It just depends on how heavy a lift it is. But we really try to be helpful to answer simple questions as part of the 5%. And also, if it's a simple workload that you're just trying to get working in the cloud, as you're learning CloudyCluster, then, you know, we help get that, you know, first workload going as well.
Great. I'm curious too, because you gave some examples, and obviously there's some extra examples in your slides, but you gave some examples of the you know, projects that particularly some through the Cloudify Gateway solicitation project. And I'm wondering, are there certain kinds of projects that are particularly well suited for this, or can this be used for all sorts of scales and types, and because I that's the sort of thing that as a non-technical person, I don't really have a sense of what the boundaries are of what makes a successful gateway using CloudyCluster as the cyber infrastructure to access cloud services.
Yeah, and I think the biggest thing that you need to look at when looking at the cloud is the really large MPI, heavy message passing jobs may not, those are things that, we're starting to do some testing and working to see, we're going to be doing some work with some climate models and things like that to see how large they can scale, what's the number of cores we really can get at with different pieces. So those are the ones where we need to spend a little time thinking. But if they're smaller or HTC jobs or, forgive me, anything like that, I think they work relatively well. You get the data there and you process the job. So there's different ways to think about things. A lot of people on premise think about storage being, everything just kind of sits on Scratch or Home or something like that, and it grows. And what's interesting is object storage opens an option, and more clusters are having object storage on premise, but that ability to do different tiering of storage. So you can do, the cheapest way to store stuff long term that you're not going to access that you need to keep for compliance purposes or something is to use the object storage. So that's an interesting model. But I think it's those large workloads that, let's have a discussion, see if they work, that they may not kind of fall out of the box.
Great, that's helpful. We have a little bit more time for some more questions. If anyone has them, you could either speak up too if you don't type as fast as you speak. What we could do also, I just shared some information about our next upcoming webinar, and I can talk about that for a moment while we see if anyone has any additional questions. So I'll do that, given that I don't see anything popping up right away. So next month, I just want to, well, first of all, I want to remind you that I've put a link to our evaluation form in the chat. So I do hope you'll share your feedback on that. But also next month, we have a webinar featuring one of our people sitting on the webinar today listening. Actually, it's his company. He's not in presenting himself, but Starfish, which is a data storage service, will be presenting about their services, and that will be Jacob Farmer. But Milo, who is on the call today, will also be there available helping out. So I do hope you folks will consider that, and we'll be announcing that through our newsletter. I do see that we have a comment from Kenneth, which says that maybe it makes sense to get Slurm/Torque out of the loop and have the metascheduler do everything. Boyd, did you want to comment on that?
Sure. I think a lot of people expect their Torque and Slurm jobs to run, and there are some things that happen under the covers, but we have been asked that before, and we're looking at doing some things with the metascheduler to even extend to things like serverless, or can the metascheduler just spin up a Kubernetes cluster and then release things to that. So we want to make sure that standard HPC works, but then we kind of want to extend beyond that, and it might make sense for definitely some of the high throughput things to maybe do some of those things. But we also want to make sure we're kind of backward compatible and people are comfortable with their jobs too. But yeah, we have thought that's a good point.
So I think I will now say thank you to Boyd, and also to Rich, who answers some questions behind the scenes, and also Amy for helping make this happen. This was really neat to hear, because I have always kind of wondered what it was you did, and beyond being really supportive of the Science Gateways community. So this is really terrific to learn about. So thank you so much, Boyd, for presenting this and presenting it while you're ostensibly traveling for personal, family, exciting events. So.
Yeah, in an Airbnb, since my son's wedding this past weekend. So, but anyway, yeah, thank you so much for having us, and appreciate the time, and appreciated all the time we spent together at the various conferences.
Yeah, thank you so much. Yep.
Thanks.
We'll see you next month.
See ya.
Bye.
Bye.